Okay, so here we have a couple little guys with their toy car accelerating just down the road there. Okay, so in this particular example video, we have a car that's going to accelerate to the right, aka east from rest, which means it's stationary to start with, and at some constant acceleration a is not given to us. And it says if the car reaches a velocity of 12 meters per second after 2.5 seconds, it wants us to find these four different parts. One, the acceleration. Two, the time needed to reach an instantaneous velocity of 18 meters per second. Part C wants us to find the instantaneous speed. So really, it's the same as asking us to find the instantaneous velocity at 5 seconds, except leave out the direction, aka the absolute value there just means magnitude. And then part D asks us to find the change in velocity during the interval of 2 to 4 seconds. All right, let's knock it out. Part A, pretty straightforward. In order to find A, apply your average acceleration function, which is change in v over change in time. Here, I've chosen to break up delta v into vf minus vi over change in time. Why? Because I'm trying to find A, and all the information is pretty much given to me. Here, it starts at rest, so I can cross vi out. My initial velocity or initial speed here is just 0. My final velocity is 12 meters per second. Here, you can write a positive 12 meters per second, or just keep it as 12 meters per second, and then you can just add the directions later. All right, so I've chosen to just go ahead and put in the 12 meters per second divided by 2.5 seconds, and then if you simplify that, you get an answer of 4.8 meters per second square. And here, I've chosen to include my direction because acceleration is a vector, or you can just simply put a plus sign in front of your statement. That's it. Pretty straightforward. All right. So just make sure you pay attention to units. Here, the units for acceleration is meters per second square. Notice in the second line of my work, it's meters per second divided by second, which reduces down to meters per second square. All right, let's move on to part B. Part B asks us to find the time needed to reach a speed of 18 meters per second. So this question mark here in the diagram, okay? All right, so to find time, again, I'll start with the fundamental function. Average acceleration is equal to change in v over change in t. But here it wants us to find time. So let's do the algebra stuff first. To find time, I will multiply both sides by t. You notice here in the first line, t is in the denominator. So therefore, algebraically, we have to get it up to the numerator. By doing so, we can go and cross out t on both sides. So here we have a delta t is equal to vf. So to isolate for delta t, we need to get rid of a. To get rid of a, here's this a times delta t, so we would just do the operation, opposite operation. So therefore, divide both sides by a. That's what it's going to look like. And t is going to equal to vf over a, which in this case, vf is 18 meters per second, because that's what part A wants us to do. How much time does it take to get up to this certain velocity? And then divided by a, which is 4.8 meters per second square, which is calculated in part A. And here, time is 3.75 seconds. Time is a scalar quantity, so there is no direction whatsoever. Okay, time is a scalar. All right, let's do part C. Part C asks us to find the instantaneous speed after 5 seconds, aka in this case, it wants us to find the VF value in the average acceleration function. So I'll start again with my average acceleration function here. To get VF by itself, I notice again for this problem, VI is 0, so I can just leave out VI. And then to get VF by itself, I can multiply both sides by delta t, as my work shown here. And then therefore, VF is simply A times change in time. All right. We're just plugging values. A is 4.8 meters per second square. The change in time here is 5 seconds, and that information is pulled from part C itself, since it wants us to find the instantaneous speed after 5 seconds. Therefore, 4.8 times 5 is 24, and the unit is meters per second. So you notice here, this is my answer. It asks for instantaneous speed. So really, find VF, except when you present your answer, just leave out the direction, because speed is a scalar, so there's no direction needed. Okay. All right. Let's do the last part, part D. Part D is a little different. It asks us to find the change in velocity. So as you practice these types of acceleration problem, understand what velocity or what speed is looking for. You know, there's a bunch of different ones like instantaneous velocity, there's average velocity, there's change in velocity, there's initial velocity, there's final velocity. So differentiate between the different type of velocities. Here in part D says change in velocity, so it wants us to find delta V. So I'm going to write my average acceleration function a little more condensed. A is equal to delta V over delta T. Why did I write like this? Because I'm asked to find the change in V, not VF, not VI. So I've learned to keep delta V in the numerator as such. So to get delta V by itself, multiply both sides by T. Hopefully now, if you've kept up with the first three parts, that step is already done for you. Okay, so multiply both sides by T to get delta V by itself. So here we have A times delta T is equal to delta V. A is 4.8 from part A. Here the change in time is 2 seconds. The 2 seconds come from the question itself. It wants us to find the change in V between 2 to 4 seconds. So the difference between 2 to 4 is 2 seconds. All right, so that's where that 2 second comes from. And then that's it. 4.8 times 2 is 9.6 meters per second. So make sure you pay attention to the units here. The unit second for the time is going to cancel out with one of the seconds in the meters per second square, which will leave you just with meters per second. And here I've chosen to include my direction because it says change in velocity, and velocity is a vector quantity. So the change is positive, aka in towards the right. Okay. All right, and that's it. I hope that helps. Stay nerdy. Don't be wired.